Now we're going to analyze a couple individual data points. I would like us to describe the Illinois' position. They are at 5.8% unemployment rate, and I'm going to use both its z-score and a percentile. So let's do the z-score first, since that's what's asked for first. To find the z-score, I take Illinois, which is 5.8, subtract from the mean, which is 4.9, and divide by the standard deviation, which is 0.98. And that gives me a standard deviation of approximately 0.918, or 0.92 standard deviations from the mean, about one standard deviation above the mean. To find the percentile, I have to find its place in the data set. So I need to go back to my calculator. I'm going to organize my list state. I'm going to do that by choosing stat. Number 2 for me is sort ascending, and I'm going to choose list state. And now it should be in order from the lowest to the highest. If I choose stat edit, and if you don't see the state list on your screen, you can go and make sure your cursor is up above in any of these columns. Choose second insert, and then choose second list alpha S, and go get the state data, put that in the column, and there we have it. I now need to find Illinois, which was 5.8. So I'm going to arrow down until I get to 5.8 and see what position this is sitting in. And it appears that 5.8 is in position number 42. I see that position right here in the parentheses. That's the number I need to carry back to my worksheet. So I can now go back to my worksheet, and I'm going to put it as place 42 out of 50, which converts to the decimal 0.84, which means it is in the 84th percentile of states. Unfortunately, for unemployment rates, it would be better to be in the lower percentiles, but Illinois finds itself towards the top of the chart in the 84th percentile. I'd like you to try the same for Colorado. You can pause the video at this point and try it yourself, and then restart the video to see what the answers are. For Colorado, the z-score would be 5.3 minus 4.9 divided by 0.98, and that decimal works out to be 0.408, or 0.41. It's about half a standard deviation above the mean of the state data unemployment rates. And then to find its percentile, I have to find out what place it's sitting in out of 50. So again, I'm going to use my calculator. I'm going to find 5.3, and if you notice, there are quite a few 5.3s. I'm going to use the very last one because this is in the 36th position. So I will bring that over here. 36 out of 50 equals 0.72. This means it is in the 72nd percentile, which means that 70% of the data has an unemployment rate of 5.3 or lower. So this is at or equal to 72% of the data. The next thing I would like to do is double check to see if my 25th and 75th percentile match my first quartile and third quartile. See, what I'm doing now is taking a look at the middle part of the data set to see if right in the middle it's behaving as I would expect it to. So the first thing I'm going to do is take the 25% times 50 data points. That puts me at position 12.5. We lop off the decimal point. I am seeking the data in position 12. And if I use my calculator and go to the 12th position, we can see right here that in the 12th position is a 4% unemployment rate. So I'm going to use that as my percent. So 25th percentile equals 4%. And what I've calculated from up above, the first quartile was 4.1%. These are very close, nearly a perfect match. Now let's see about quartile 3. 0.75 times 50%, or times 50 states, gives me place 37.5. Ignore the 5. I'm looking up position 37. Go back to my calculator. Go to position 37. Going back up the other way. I find an unemployment rate of 5.4%, position 37. So I am going to use that percentage, 5.4. So we have the 75th percentile equaling 5.4% unemployment rate. And if I use the table above, third quartile is at 5.5%. This again is very close. So my conclusion here can be that the middle of my data is matching the IQR to the percentiles. What Chevy-Chev has done for us is he created the formula that lets us know worst case scenarios in any distribution whatsoever. If you go out one standard deviations, as you can see by plugging in the one standard deviation, squaring it, subtracting, he doesn't guarantee that any data will be living within one standard deviation of the mean of any distribution that looks nice, neat, skewed, or is very unusual looking. For two standard deviations, Chevy-Chev is guaranteeing us that there's a 75% amount of our data within two standard deviations of the mean. For 3, it's 89%. 4 is 93.75, and 5 standard deviations plus or minus should give us 96% of our data no matter what our distribution looks like. So we are now going to test Chevy-Chev against our current data set called state, remembering that our mean is 4.9. That is our x-bar, and our standard deviation is equal to 0.98. I'm going to use these values and check the places of the data. So for the first one, I'm going to take 4.9 plus or minus 1 times the standard deviation. And if you do that in your calculator, you should get 3.92 as the unemployment rate to 5.88. I need to make sure I inbound this, and you'll see what I mean by that when we take a look at our data set. I want to find out where 3.92 is. All right, I'm at the beginning of my data set. 2.7 is outside. It's below 3.92. So is 3.1, 3.5, 3.6, 3.6. 3.9 is very close to 3.92, but it still is outside of that range. So I have to keep going past there This number 4 is the first thing that is actually inside the range of 3.92 to 5.88, and it is positioned